Hi everyone, welcome to my YouTube channel Code and Canvas, and in this video we will learn about different parameters that we use to control output from an LLM. So first of all, let's understand how an LLM generates a text. So while generating a text, LLM does not pick the best word. Like let's say there are different words we need to choose for. It doesn't pick the best word. It chooses based on probabilities. So it applies different probabilities to different options, and based on that, it chooses the next token as the output. So let's say imagine a bag that has a possible next words. Some words are very likely, some are possible, some are weird but interesting. So output parameters which we pass to an LLM, they help an LLM in deciding how to choose that word. So how wide the guesses can be, how long it can talk, and when it must shut up. So they tell LLM how to choose that word, how long an answer can be, when to stop generating tokens, and what method to choose in choosing up a token. All these can be controlled by the parameters we pass through LLM, and we will see all these parameters in detail one by one in today's video. So one sentence truth is that LLM does not generate sentences. It generates only one token at a time by guessing what comes next. So when you expect an answer from the LLM, it doesn't generate a paragraph or a sentence in one go. It takes care of the context, whatever context you are providing in the input, or whatever context it has from its past conversation. It takes into account into that, and then choose a token, best token that can fit into the answer one at a time. So when all the tokens are completed, it forms a sentence, but it doesn't form a sentence in a single way. It generates a token one by one. So as I also have explained about token in my previous video, I'll do it again. So token is a smallest chunk of text that an LLM can actually read, process, and generate. So for example, let's say there are different words. So token can be a full word or a partial word. For example, a word can be divided into 2 or 3 tokens based on its length. So for example, cat is a full word and can be a single token as well. But for example, words like running, ChatGPT, recursion, these are lengthy words, right? So they can be broken or may not be broken into different tokens. For example, let's say recursion might be a single token, but ChatGPT and running can be broken down into 2 different tokens, like running and ChatGPT. So LLM thinks in tokens, not words or sentences. It can be character, word, number, symbol, or emoji. So in a token, it can be anything. It doesn't need to be a character or a string of characters. It can be anything. It can contain a number, symbol, emoji. Obviously, emoji sometimes take the whole token, but yeah, it can be anything. Whatever is possible in the output can be divided into tokens. So when choosing a token in the answer, model chooses it based on the probabilities. Let's see that. So for example, let's say we are providing a prompt in which we are asking for the capital of France. So let's say we provide something like this: the capital of France is. So internally, model will take all the possible words that can be produced in the output. So let's say all the possible words are like these, like Paris, Lyon, beautiful, unknown, and all those things. So it will, depending on the context and the knowledge or the training it had before, it will assign probabilities to each of them. So here again, it might not be the answer might not be a single word. It may be a lengthy word. So it can be a token. For example, let's say the answer is Paris, right? So it is possible in first attempt it will just choose a token, for example PA, and in the next attempt it will choose the token RIS. So it will not always select the whole word as the next output. It will select the token. So the answer could be broken down into different tokens, or it can be a single word. So let's assume that all these words are single tokens right now. So let's say the probability that is assigned to Paris is 0.72, Lyon 0.08, and so on. So based on the parameters that has been provided to it, like temperature, top P, top K, we will see about them later in the video. It will choose the token with the highest probability most of the time. So here, as the token Paris has the highest probability, it will choose it as the next token in the output. So these probabilities, they come from training. So the training, it has already on different vast knowledge, or the context that you provide in the input. Based on all that, the probabilities are decided, and tokens are chosen, and output is returned to the client. So let's see all the parameters that affect this response one by one. The first one is temperature. Temperature is a parameter that controls randomness in a token selection. It reshapes the probability distribution before sampling. So a short summary is, when the temperature is too low, the model is safe, repetitive, and conservative. And high temperature makes it creative, surprising, and risky. So let's take an example to understand that. So let's say the original probability distribution for the same input. Let's say Paris is 72%, Lyon is 8%, and Marseille is 6%. Now let's say we tweak the temperature to low or high values. So temperature value can be from 0 to 2. So some models may allow you to set the temperature to 2, some may allow you to set the temperature to 1. But 0 is the lowest, and 1 and 2 may be the highest temperature possible that is allowed to set on a model. So let's say we set the temperature to a low value, which is 0.2, then the probability of Paris will go up. So it will be 95%, Lyon 3, and this one 1%. And if you set it up too high, let's say 0.9 or 1, then the probability of Paris will go down as compared to the previous settings. So Paris will go down to 40, Lyon will increase 25, and Marseille is 20%. So I'm not saying that low probability means the output will never consider those tokens. Low probability is just to say that they have less probability to get chosen. So as Paris has high probability and low temperature in the default one, most of the time, almost 100% of the time, Paris will be your answer, because the input that we have chosen here is like a factual one, right? Like it will not change regularly, like it is a fact. It will always be Paris, right? The correct answer will always be Paris. So for such questions, the next token, whatever temperature you choose, will always be Paris. The probability of Paris for such answers will always be high, even if you tweak the temperature to a high value or a low value. But in case where the answer is not a factual, or for example summarizing a document or writing a story or things like that, there you will see some difference how the answer is being written. So we will see a demo of this probably in the next video. So in this video I will cover all the theory about all these parameters, and the next long video will cover demo on all these, along with how to call a LLM SDK APIs. So let's continue. So here, as you can see, temperature is 0.2. The API set of rules that allows software programs to communicate. So as you can see, low temperature is needed for the task where you want where the task that you're performing is not that much creative. For example, writing code or factual answers or things like that, summarizing documents and all. So for those things, you might want to set up a lower temperature. So one thing you need to understand, even with the lower temperature, there is a possibility that you will get a wrong answer. For example, here instead of Paris, you might get Lyon. But probability of getting Lyon as an answer instead of Paris for such a factual question is like really low, like almost close to 0%. So almost 100% of time you will get the Paris as an answer, because that's a factual question. But in case of tasks like story writing or the creative task, things may differ. So please remember that nowadays these LLM models are being trained on a lots of data, and they have a long years of training behind them. So probability of giving a wrong answers to these kinds of questions, or writing code about a program or something like this, it's highly unlikely that they will produce a wrong output. But in case of creative tasks like story writing and all, the number of words that a model will choose while writing a story will be different based on the temperature. So when I will give you the demo, you will see that when we ask a model to write a story in a very creative manner, then temperature plays a key role in the number of words or the tone or the way the story is written by the model. So when we are working on a deterministic task, like code, writing a code, or summarizing a document where where we do not want model to think outside the document context and all those things, we set the temperature to a low value like 0.2, 0.4 and all. But when we want a model to do some creative task like writing a blog, writing a story, or thinking of ideas and all that, we want our model to be more creative. So we want it. We set up the temperature to a bit high value, for example 0.8 and 1. So these are like different scales where a temperature is defined for a model. So 0.0 is like a robot mode where we usually use it for APIs, test, fixed answers and all. 0.1 to 0.2 is like safe, and 0.3 is for like, so 0.1 to 0.4 is like safe value. So we can use it for code, facts, definitions, tutorials, explanations where we don't want models to be more creative. Then 0.5 to 0.6 is a balanced, like for this can be used for teaching, Q&A, and again for simple coding and all as well. Then above that, above 0.5 and 0.6, it's like it started become creative. Like from 0.7 to 1, it becomes creative and it can be used for blogs, stories, poetries, metaphors, and all those kinds of things. We rarely set temperature greater than 1. Also, many models do not allow you to set the temperature greater than 1, but I think some of them do allow to a value of 2. So there a model can become chaotic. So as you increase the temperature, these distribution may vary randomly. So you might get unexpected answer if you set up the temperature to a very high value. That's why most of the models do not allow you to set the temperature more than 1 or 2 using APIs. So when temperature gets too high, it's extremely unlikely tokens becomes almost as likely as good ones. What does it mean? It means the probability that is assigned to both the tokens, for example in this case Paris and Leon, they might be very close. For example, Paris might be 40 and Leon might be 39. So there is a good chance that you might get Leon as an answer instead of Paris. So grammar rules stop mattering, coherence collapses, and you get words, syllables, repetition, or nonsenses. So obviously, you may get repetitive words, you may get nonsense in your nonsense facts in your answers. Model will still be like may sound confident, but the answer may be completely wrong. So an example is there. For example, normal temperature, Paris is the capital of France. But very high temperature, it can be doing anything. Like it will choose random tokens as well. Obviously, it will not be this bad because of the all the training that it has received over the years and all the knowledge it has gained from the queries of the people. But it is a possibility the model may behave randomly. Now let's look into the another param which is top k. So top k limits the candidate tokens to k most probable ones. So here it decides in temperature, it distributes the probability to all the tokens, possible tokens, and some will always be 100. Then it chooses one among them. But what top k does, when you say choose top 3, for example, let's say the value of k is 3, then when after distributing the probabilities to different tokens, it will pick up the most highest 3 tokens from the group, and it will choose one of them, one among them only. It will just discard all the others. So let's take an example. Let's say a model has 1,000 possible words. Let's say top k value is set to 10. Then it chooses from the top 10. If the top k value is set to 1, and then it chooses the most highest one. For example, let's say we have 5 tokens A, B, C, D, E. If the top k value is 3, it will choose among A, B, C since these 3 are on the top. Then if the top k value is 1, it will just choose A because it has the highest probability associated to it. So that's how top k works. It's different from temperature because in temperature we do not discard the lower probability tokens. Obviously there is a very rare chance of getting the lower probability token, but we do not discard it from the calculation. But in top k sampling, we just decide the output from the tokens from the top from the top k value. So here is a table again. So top k1 means no randomness, only the strict systems like whatever is on the top, pick that up. 10 to 20 is a control one. So model for each token, it has 10 to 20 options, and it's a creative mode. 4050 is still it's a default value, it's a balanced value. It chooses from the 4050 tokens, and then 100 plus can be like a loose mode, which can be again used for creative tasks like writing stories and all those things. If top k is equal to 1, you might get the same answer every time. If top k is 50, there will be slight variations in each run. So again, this may not be always true. For example, for questions like factual ones, this will not be always true. But for for task where the model might need to write a paragraph or things like that, this will be true. So let's say problem with the top k is that let's say for some factual questions, for example, the above one. So here, let's say a token has a highest probability of 90%. Then there is a two tokens B and C which has probability of 1%. There are other tokens which has probability is in like less than 1%, like 0.8, 0.4, things like that. But let's say we have set the top k to 3. So as we now know that answer of that particular problem might be in token A, because it has a very high probability for choosing the token, right? But because we have set the top k to 3, model might still look into the token B and C. Even they are very less in probability than A, but there is a very rare chance that model might pick up B and C instead of A. Because here we are saying just to choose the top these tokens that are on the top based on the probability. We doesn't say about the model, we doesn't tell the model that if probability reaches 90%, don't look for other tokens, because that is the best one. We here say no matter what the highest probability of the token is, pick up the topmost tokens, then choose among them. So the token that has very low probability might come into the calculation and they might affect your answer, which again will not always be true, but it can happen. So to avoid that, we use another param called top p. So top p is different from top k because it says pick up the token until the probability reaches a some percentage. Here we are given the number of tokens, the exact count of token that we need to pick up from. But top p is different. It gives the cumulative probability value when the tokens that has been selected for the output reaches when the cumulative sum of tokens that has been selected for the output reaches a p% probability, then stop. So for example, let's take this example again, ABC1. So here let's say if we set top p to 90%, right, then as the first token that we see here, it satisfies the condition, right, because the sum of cumulative tokens is 90%. Then it will not look into B and C. Similarly, let's say if the top p value is 91%, then it will take in the account of A and B, because the sum of A and B is 91%, right? It will not take into account the C token because the sum will be more than 91%, right? So top p says pick up tokens, select the tokens for the output until unless the cumulative sum becomes equal to or greater than this particular p probability. So let's again take the same example. So let's say the top p value is 80%, 0.8. Let's say the Paris has a percentage of 72%, Lyon has a percentage of 8%. Then only allowed tokens in the output are Paris and Lyon. So if the probabilities were lower, for example with high temperature and all, so let's say Paris is this, Lyon is 25, Marseille is 20, Nice is 10, then 0.4 would include 4 tokens, not 2, because sum of these 4 is still under 80. So that's how P works better than the top K parameter, because it adjusts model confidence and avoids junk words. By junk words I mean the tokens which has very less probability and should not be chosen in the output. So this is again a comparison table. So from 0.03 it's like safe for facts and compliance for writing code and all those things. From 0.5 to 0.7 it's controlled, so this can be used for tutorials, teachings, all those things. So up to 0.9 it's safe. More than 0.9 it's like creative, it can be used for writing stories, for generating ideas and all those things. Then another parameter we have is max tokens. Max token is simple as the name suggests. It just tells the model to return this much amount of tokens. Please note that I'm not saying words, I'm saying tokens. So for example, a word might be cut into different tokens, right? So it simply tells the model in the answer return at max 200 tokens. So for example, max tokens, let's say 8. Let's say we have a question, we are asking the model about recursion. Then as the max tokens is 8, the answer could be like this: recursion is a technique where a function calls. As you can see, the answer is not complete, right? Because the complete answer require more tokens than the 8 token, right? So here I have taken a word as a token. For example, recursion is a token, but in reality recursion will contain more than one token, right? So the answer will be shorter than this one. So it just tells the model return at max these number of tokens in the output and stop after that, no matter the answer is complete or not. So it matters when you want to control the cost, because cost is highly dependent on the number of tokens being input in the model or coming from the model. So when you want to control the cost while getting an answer, and you do not want the lengthy answers and all those things, then you can use this param to control the output of the model. So for example, when you want a one-liner answer, 30 to 60 tokens are used. A short explanation needed 200 to 500 tokens. A blog and things like that may need 800 to 1500 tokens or more. And code, it depends on the complexity, right? Code might need a lot of tokens. Then another param we have is stop sequence. Stop sequence, like this max tokens, control the output and restricts the model to stop generating the output when the condition is satisfied. So here we provide different sequences. So you can provide multiple sequences. Here we provide an array of sequence, and we ask model to stop generating the token when this particular string token or this particular sequence appears in the code. So for example, let's say you are generating a JSON, right? Single level JSON. Then you want your model to stop generating anything once this closing curly brace appears. So let's assume your JSON does not have a multi-level JSON. It's a single level small JSON. Then you can just say you can expect your model to return the answer in JSON format and do not generate anything after this closing curly brace is generated. So that's what it tells the model. It will just tell the model if anything from the sequence is generated, stop generating after that. So it can be used to prevent model from continuing after the answer is complete, or enforce a structured output, or stop before hallucination appears. So forgetting stop sequences can also get you extra cost. For example, let's say you want only a small JSON from your model. So let's say model may generate explanation or a paragraph or something after that as well, right? So here you can stop the model as soon as the curly brace appears. It will stop generating tokens after that, and it will not give you extra random text that you might not need. So a rule here is that you need to use stop sequences when only the structure matter. You want your answer to be in the same structure, or you want your answer to end when a particular sequence occurs in their answer. Then you can use these kinds of parameters. So here is a determinism versus creativity trade-offs. So let's say if you want deterministic outputs means you want fixed outputs, like for facts or for your code, or anything that is factual, like summarizing a document where you don't want model to hallucinate from the global knowledge, like from internet or something like that. You want model to look into the document and give you the summary of that. Things like that. You can use parameters like these, like temperature can be set to 0, top K1 and top P disabled. So it's used for APIs, unit tests, production pipelines, complaint systems and all. Obviously for coding, temperature can go up to 0.3, 0.4, but it will make the model more deterministic. Then when you want creative outputs like story, blogs, ideas and all those things, then you set up higher temperature, higher P value, and you don't set up the top K. So here it's used for brainstorming, writing, teaching metaphors, idea explanation, and all those things. Okay, that is all for theory. So in my next long video, I'll give a demo on all these sequences. In that video, we will see how to call a LLM SDK API from code, how to configure that, and how to set up all these params along with two more, and how the output changes based on the values of these params. So thank you very much. See you in my next video.